couple of seconds for Twitch to catch on. Oh good, I can raid whenever I want to, according to Twitch. I'll get right on that, whatever that means, and you felt it was important enough that it had to be over the top of my channel, so go for it. Let's tell the world that we're streaming. Streaming Game Day of. Streaming a Game Day of. We are. Fun stuff. So, now that we are streaming, let's have some fun. I am in a thoroughly ringed out mood. I programmed on incredibly obnoxious problems on production servers all day. And then I come home and some shit gibbon FEMA'd me. And now I have to program. So I'm not in a great mood, and we're going to try and get around that by doing stuff that I like, and that is making spaceships do stuff. I could also model stuff if I decide that if my brain stops working and I have to give it a break, then I will model stuff instead. Either way, we're going to get some stuff done. So in the last episode, what we did is we made the ships break into chunks. And that was quite an annoying little feat, but now that that's done, the hard part should be done. Now all we have to do is activate tasks. And we've got a whole bunch of tasks already kind of baked in here. This one's nothing. We can go ahead and delete that one. But there are a lot of tasks baked into our setup. Over here in the engine, we've got this task script, which has no particular comment or anything like that. And what we're going to do is we're going to assign people to it. But first I'm going to change the unimportance to importance. I changed my mind on that. Grind. Importance. Exciting. Okay, so these tasks are things which will become steadily more critical as time goes on. And you have to assign people to them if you want them to be okay. Basically, as the tasks go on, they have a counter. So we're going to go ahead and put that in here. Public float hours passed. And the more time passes here, so we'll go ahead and put that in. The more hours pass, the worse the condition for most tasks. That's not true of all tasks. For some tasks, it'll be the opposite. Rather than decreasing something, it'll increase something if you do it, and then it'll steadily return back to baseline. But I haven't really decided on the best structure for that stuff. What we're going to do today is we're going to focus on actually assigning these tasks. So the very first thing we're going to need to do is create a bunch of people. We don't have any people, so that's what we're going to start with. So here we are. Crew member. Ba-boom. Crew. Excuse me. Public, namespace, crew. And tab that over to the side, and let's get started. So the crew members are going to have a lot of stats in the long run, but for now they don't need any, because what we're going to be doing is assigning them to tasks. So I lied. They need one particular thing, and that's going to be current assignment. There we go. So with the current assignment set up, we're going to be able to tell whether a crew member is ready to boogie or not. We're also going to have things like exhaustion and that sort of stuff. We'll deal with that later. For now, we're going to keep it real simple. So over here on the task, when we are going to find a task, what we're actually going to be doing is every hour, we're going to be looking through all of the crew members in a location, and we are going to assign any of them that don't have tasks to whatever tasks we can find. So in order to do that, we're going to need to modify the crew member lounge, the crew quarters, these. So these have a couple of elements to them, but the biggest thing they're going to need is a list of crew. So public crew. And we're just going to go ahead and brute force it for now. Later on we can polish it. A crew member, my bad. Come on. We're going to just return get components in children crew member. We're also going to need to get all of the ready crew, all of the resting crew. So public list crew member, what is it called? Resting crew? Ready crew? I can't think of a better term. So from here, we'll create the list. Equals new list crew member. Yay, that started to work. And then we will tell it to fill it up, and then we'll return it. So to fill it up, we're just going to do for each crew member m in crew, in this.crew. And then we're just going to say if m dot duty, no, dot task, current task. Let's go ahead and just call that task. There's no reason to call it something complicated. If m dot task does not equal null, if it does equal null, then we'll add it to the list. There we go. And I probably shouldn't name this crew. We'll call this resting. Or just call it list. There we are. No more annoying tendency for me to use the same word twice in different scopes, which is generally a bad idea. All right, so we now have the ability to get a resting crew. So down here in the hour update, what we're going to do is we're going to go through that crew. So for starters, we're just going to test and make sure it works. So we can't actually do a for each on this. Oh, yes, we can, because it doesn't get modified until after the fact. That's fine. For each crew member m in resting crew, debug.log crew member plus m.name plus is ready to deploy. Exciting, right? Of course, the problem with this is that we don't actually have any crew members set up at the moment. So to do that, we're going to drop some crew members into our room here. We'll just create an empty. Why did it go up there? What a bizarre choice. Create an empty. Okay, so apparently it will never get created in the right spot. That's fine. We can live with it. This is going to be Alice. And we'll drop Alice's crew member badge on. And then we'll have a Bob. And then we'll have a George. Nope, come on. So now we have 3 crew members. And if we look over here at the console, it looks like there is some debug that we can get rid of. So we'll go ahead and do that. No reason to have these here. And then we'll hit play. And every hour you can see how they're ready to deploy over and over and over. Perfect, right? Now all we have to do is actually deploy them. So to deploy them, we're going to have to modify this task a little bit. So public list crew member workers. All the workers for this iteration of the task. We're also going to need to keep track of how long this is going to take. So public int base task length equals something. We don't care what. How many hours this takes ideally. Now that length will be increased by specific values. So int task modified task length equals 0. How many hours? No, we're just gonna call this. Nah, that's fine. How many hours? How many additional hours due to whatever conditions? And then we're also gonna have a task length, which is just going to be a get return base task length plus modified task length. Basic stuff, right? So after that, we're also going to need a counter. Public int time elapsed equals 0. When this reaches the task length, the task is done. All right, so this is very, very basic stuff. Nothing complicated, which is good because my brain is not really working today. But that's fine. It hasn't been working for about a month now. We're going to go ahead and have this actually have an hour log. So to do that, we're going to need something which signs up. So public void initialize. But I don't know whether initialize is a reserved word, so we're going to call it setup. When we set it up, what we're going to do is we're going to say that time elapsed equals 0. And we are going to sign up for the on-hour elapsed. And that's just universe.onHourPass plus equals hour pass. And down here we'll have a public void hour pass where we'll do time elapsed plus plus. And it has to be an add listener. There we are. That's fine. And lastly, we're going to want a complete. So public void complete. And all of these should be virtuals so that we can descend if we want to later on. But now that I'm thinking about this, I want the hours to pass regardless of whether we're actually performing the task. So we're going to move this into awake. And then public, oh, we don't need to unassign it. That's fine. The unassignment will be handled automatically by Unity. How handy. So here in setup, we're going to just have a time elapsed, and then we got complete. So debug task completed. And then what we'll do is we'll go through and unsign up all the characters. So I think we're going to use an event for that. Using Unity Engine.events. And we will have just a couple of events down at the bottom here. Public Unity event on task complete. And what we'll do is down here we'll say on task complete.invoke. But we're also probably going to want to unassign all of the people who we have logged. So for each crew member M in participants, crew, workers. M dot, we're going to have to do some complicated stuff here. So I think we're going to need to have a function for it specifically. Task completed, this. And we're going to go over to crew members and add that in. Public void task completed, task target. Now you notice that we can pass it tasks besides the task that we're actually signed up for. And that's fine. There are times when I might want to use that capability. So I think it's okay. And we're just going to go ahead and assume that it's going to be the same task. So if task does not equal target, we're going to throw an exception, just a warning, just in case. So debug.log warning completed a different task than we were assigned. Plus target.name. And we're going to go ahead and say name plus, there we are. Actually, we're going to go ahead and have that be a say. And up here, we're going to go ahead and create a new say command. Public void say string dialog. Debug.log name plus dialog. Later on, we'll be replacing that with an in-universe pop-up of some kind once we have, actual portraits and stuff. So it's better to centralize now so that we can switch it out later. And then we'll return. Otherwise, we say task equals null. And we should also, to do, make us tired. Excuse me. here, what we're going to do is we're going to go ahead and check whether we're running or not. So we're going to need to have a running. Public bool running equals false. So if we are running, then time elapsed plus plus. Otherwise, we have this hours passed here. Here in complete, we're going to reset hours passed back down to 0 after everything else. So hours passed and time elapsed are too similar. I think I should rename at least one of them. So let's rename this one. Hours passed since completion. And that will help us to remember which is which. And we'll change time elapsed into runtime. There we go. Now they are distinct. Although they are clumsy, they are still distinct, and that's good enough for me. All right, so we've got everything set up more or less correct, except that we forgot to tell this to actually turn on. So running equals true. And down here, running equals false. Woohoo! So now, how do we actually set up the crew to do this? Well, that's the role of the crew quarters. Over here, we're going through all of the crew members, and we are trying to send them to a new place. We're gonna go ahead and have a count. So, well, you know what? I'm trying to think of the best way to do this, and I think that, yeah, we'll go ahead and count it. So, list crew member waiting equals resting crew. Otherwise, we'll be recalculating a lot of times. So int num resting equals waiting dot count. And the reason we're doing this is because we're going to do some shenanigans later on where waiting will contain people who are no longer waiting. So let's not note that down. Later on, waiting may contain less people than... No, wait, it should be fine. We'll just go ahead and use waiting. Yeah, it's all good. But we can't do this for each loop. So for int a equal, I'll just do a while loop. While waiting.count is greater than 0, infinite loop until you explode. So we're going to go ahead and find all of the tasks we can get. So tasks array, is it list tasks? Tasks equals get tasks. I think that crew quarters doesn't descend. It does descend from functional room. Functional room actually has a get tasks of some kind. Let's go over there and find it. Tasks. Okay. So with this crew quarters, we're going to want to pass it the tasks that we have. So tasks, there we are. We need to pass this a door. So we'll need to go ahead and pull out the doors, and we're going to have exactly one door. So crew quarters always have exactly one door. So here what we're going to do is we're going to go ahead and say if waiting.count equals 0, then debug.log all crew busy. Return. If tasks.count equals 0, then debug.log ship is in ship shape, no tasks available. Return. Synthrio says black screen, yay. Are you getting a black screen? Because in my video preview it's working fine. So I hope you're not getting a black screen. I'm going to go ahead and chat it. You can't see the stream. It shows... So while we're waiting, we're going to pull the first crew member out of the list and just, you know what? We should move this up into the loop. While waiting.count is greater than 0 and tasks.count is greater than 0. All right, Synthreos is going to reload and see whether that helps. All right, so we've got waiting and tasks, so now the job is to assign them to the tasks. One thing I didn't do, though, is I forget to specify these tasks can take any number of workers, so we should probably put that in. Public int required workers equals 1, and we may also have public string required worker job or class. We are not going to worry about that yet. We don't need it then. Just delete it for now. Yeah, there we are. So over here, we're going to pull in the crew quarters waiting people into the various tasks. So we've got someone who's waiting and we've got some tasks. So we're going to just start assigning them. Now the tasks we have are not sorted well enough. And that's actually the fault of the tasks command, now that I'm thinking about it. So we're going to pop on over into the tasks command here. And we are going to have it calculate out... Oh, sorry, it's in here. There it is. We're actually going to have it calculate out a sorted set of tasks. So list tasks equals this. And then return tasks. And what we're going to do is we're going to have to sort the tasks. So Synthreos said that there was just an ad that froze the stream. Yeah, I can't do much about that. You're welcome to use ad blocker. I have no fondness for ads. Tasks.sort. And when you want to sort something, you have this comparer that you can send it. And we don't currently have an iComparer, but we can make one. So protected int iComparer. No, it doesn't seem to be how you do it. I can't remember how to do it. Public iComparer. There it is. Sort task. Task A, task B. Now I've forgotten how iComparers work, so I'll just quickly Google that. I can't remember the exact... Oh, it's iComparer task. Oh, it's just an int. So we'll just use an int. Do I actually need to? I think I can do this without... Wait, is this the reason I didn't like C#? Because you need a class specifically to do this sorting? What a friggin' stupid piece of shit. I can't remember whether or not this is doable in any other way, but let me just quickly comparison. So there's an iComparer and an iComparison. Okay, so this just says... Okay, so they actually have a different way of doing it that looks kind of interesting, so we'll try it that way. So basically what we're doing here is we've got an int sort task, and we're going to just return -1, 1, etc. So if a.importance is greater than b.importance, return -1. If b.importance is greater than a.importance, return 1, return 0. Just basic stuff, right? And then over here, what we're going to do is we're going to create a comparison. Comparison. No, we're not going to create a comparison. Now I've lost track of where we were in the file. There we are, comparison. So we'll create a comparison that is of type task. Comparison equals new comparison. Task and compare. What do I pass it here? Oh, the function, of course. Dir sort task. And then we can just say tasks.sort and then pass it in comparison, like so. And that should give us a sorted set of tasks, sorted from most important to least important, in theory. Let's see whether or not that explodes. Because this is the first time I've used that particular method. I've always hated sorting arrays in C# or sorting lists. It should be easy, but it's never easy. Still, it's good enough. So Cythrios says, I want to ask if you'll ever do C# coding in SE videos or streams. So SE is Space Engineers, which I played like 5 years ago. I don't play it anymore, but I actually did an entire set of coding tutorials on it, both how to code mods and how to code in the game. None of them run anymore because that was actually one of the main reasons I stopped playing Space Engineers. They kept changing the underlying API and the underlying structure of the code base and completely screwing up anyone that was making mods or coded in-world assets. So it definitely does use C#. It uses a very limited and clunky version of C#, but it's still C#. But because they keep breaking it, it's not really worth trying. Of course, that was 2 years ago. I stopped 2 years ago. Maybe they've settled since then. I would sure hope so. All right, so we're now sorting the tasks, which means that the tasks are already in the order. Tasks are already sorted from most to least important. So down here, we're going to grab the task that we would like to fill. Task current equals tasks 0. And we'll just pop that off the stack. So once we have the current task, we need to figure out if we have enough people to fill it. If waiting.count is greater than or equal to task, our current, I will call it task. There's no reason to. There we are. Task dot workers required workers. So we'll just say less than. Not enough crew. I'm going to make that a debug.log, not enough available crew to do task, and then task.name. So if we do that, we'll eventually run out of tasks as long as we have tasks that are too expensive for us. Otherwise, we have enough people, we should just assign them. And for now, we're just going to assign the first n people. So to do that, pretty easy. We're just going to say for int a equals 0, a is less than task.required workers, a++. And then we say task.workers dot add, and then waiting 0 dot remove, or waiting dot remove at 0. And that should do the trick, except of course that we aren't doing it the other way around. So waiting 0 dot task equals task. Perfect, right? And then down here we just say task.start, .init.setup. There we are. In order to actually do this though, we're going to need to reset the task. So we're going to go ahead and say task.reset and then task.setup. So over here in task, we're going to create a reset function. And the reset is just going to clear any variables that might cause us trouble. So this, for example, should go in reset. And then here we'll call this run rather than setup. And then here, this is going to be resetting the workers and the path. And down here in run, we're going to want to set up the path. So determine path. So over here in our crew quarters, we're going to reset it, which will do all that stuff. And then we're going to assign it the stuff. We're going to need to set the quarters. What is it called? It's called start position. We're going to call it quarters. Quarters. I should have renamed it. Hold on. Let's try that again. Boom. So we're going over to the crew quarters, and we're going to say task.quarters equals this. And that'll allow it to actually establish its pathing. Once it's got its pathing set up, we're good to go, right? So all we need to really do here is try it out. Now there is some risk that I've overlooked something and we do have an infinite loop, but I can't see any holes in the logic. Still, to be safe, we're going to go ahead and save the entire project before hitting start. All right, so what we've got here is there's no path from this the dorm integrated to the engine door, which is pretty unusual. So I have currently got all of the pathing turned off, the visuals turned off. And I think what might be wrong is that I have to reset the ship again. This is a whole bunch of stuff where I have random crap that I should do, and I keep forgetting to do it. Nope. Okay. So let's quickly take a look and see what the heck's going on with it and why it's not correctly set up. If we look at the path element here, we got a path to the bridge, the hallway rather, and then from the hallway we've got a path to the small bridge chamber here, and then from the small bridge chamber we have a path to the other hallway, which has a path to the other hallway, which has a path to the engine door. So all that means is that there's something wrong with our attempt to find that door, which makes sense. It predates our current setup, so I probably have to reprogram it. Here in determined path, what are we going to do? We're going to reset the ship-wide pathing to do, don't. And then we're going to say if there's no quarters, then we don't need to worry about that. And what we're doing here is we're finding the path between the element of the crew quarters and the duty. So duty.getComponent path element. And if we take a look at the duty is not on the door. I mean, it's not on the, is it? So here's the duty, and then here's the functional room, here's the path element. So the duty is in fact on that. We're going to go ahead and replace this though with just a getter so that it's a little bit more invulnerable later on. So public path element, get, return get component path element. There we go. So now that we have that, we should be able to find the pathing, but for some reason it's failing. So let's pop over to the pathing between. And all this really should be is something we've done hundreds of times before. So the question is what's going on? And we're going to go ahead and just add some debug. Debug.log target or name plus target.name. And then we're just going to see what sort of spam we get. All right, so here we go. We are doing the dorm integrated to engine door. Then we're doing the hallway to engine door, then the small bridge chamber to engine door, then hallway 1 to engine door, then hallway 2 to engine door. So we're definitely getting there because hallway 2 and engine door are actually just flat out connected. If we take a look, there's the engine door. It's right there. So for some reason, this is not returning the correct value. We're just going to go ahead and take a look down here. If neighbors.contains target, then debug. There we are. Let's go ahead and see if that works. Now I should probably make a visualization for this, but I want to be done with this idea. Here you can see that it's actually triggering. hallway 2 to engine doors right there. So I'm not quite sure why it's... Ah, here's the problem. Oh, no, wait, it's right above it there. There it is. See, I already got it. I've already got it bypassing it if there's a negative one. So for some reason, it's returning something I'm not expecting. Let's take a quick look here. Debug.log path. So here's the generic list. Oh, great. I forgot that this doesn't actually do a proper debug where I can actually open it up and see. It just prints out the name of the thing. Great, thanks. So we're going to go ahead and give it path.count just to see whether or not this contains any data. Okay, so it's coming back as a big fat 0. Why? This is really quite strange. Let's see whether or not this is getting triggered. This pathing system is just giving me nightmares. It should be really, really straightforward and easy, but for some reason, it's not. So it looks like the small dorm is returning a 0, as if it's being called twice. Let's go ahead and take a look here. It might be. It doesn't really matter. So debug.log this.name. Queried. And then down here, what we're going to do is we're going to go ahead and keep track of the best length here. So debug.log best len for this.name. It's returning a -1, so I know that it's not actually hitting that with the final setup. All right, so here we can see small dorm integrated, queried, hallway queried, bridge chamber queried, hallway 1, hallway 2, best length for hallway 1, best length for bridge chamber, best length for hallway, best length for small dorm integrated. Oh, would you look at that? It actually didn't fail that time. So let's go ahead and put in a worked. Maybe the problem is that the second time it fails. That's a little bit odd, but let's try it. Let's find out. Over here in the task, we got a determine path. We're going to debug.log found path. Grind, 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 and play. Okay, so here you can see what's going on here. What we've got is a setup where we initially go fine, and when we come back, we actually have a found path for the tasks. Down here, we do it again, and then it immediately crashes. Are we? No, we're not combining. We're not collapsing. So, oh, I forgot to clear. Of course, I'm just an idiot. Okay, so I found it. No biggie. I know what the problem is. Already tried needs to be cleared whenever you do this pathing between. But only the first time. So, so here we'll just go ahead and add in an if initial call. then already tried.clear. And we'll go ahead and delete that. Don't need it anymore. And over here in the task, we'll just make sure to pass it the initial call. Perfect. So now we shouldn't have that problem anymore. I knew it was something dumb. Yep, works fine now. So we're going to go ahead and quickly find all the places that are just spamming us with garbage and get rid of them. I don't need them anymore. Right. So the last thing we have to do is we get all of the tasks, but then we forget that we only want the ones that aren't actually running right now. So we actually keep getting the same tasks and trying to fill them over and over and over. So to avoid that, we're going to clear out the tasks that that are running. If they're running, we don't need to worry about them. If tasks.running, is that not public? It is. Oh, I put in an S, didn't I? If tasks.running, then tasks.remove at a and a minus minus. Basic stuff. That way, we won't run into this problem. Now what we should see is that we run out of tasks before we run out of crew. I don't think that's Unity's fault, Cythrios. That's me not clearing cache properly. So you can see that we've completed the tasks, but we currently don't have any method of monitoring how the tasks are going. If we actually pop over to the task, you can see that the runtime is steadily increasing, but we're not checking to make sure that the runtime is lower than the total amount required. So that's our next step. We're going to have to create some visuals for this as well. Over here in run, or in hours pass, we just say runtime plus plus, which is fine. What we'll do is up here in runtime, we'll do that as an underscore runtime, and then we'll do a public int runtime. This will be protected. Get and set. So if we get, we just return runtime. But if we set, we actually want to check and see whether or not runtime is higher than the task length. If task length is less than or equal to runtime, then complete. Perfect. Bum 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 bum. Oh, the tasks never got assigned? Really? Huh. Let's try that again. Here's a task. I got assigned with Alice. Oh, it just never said it assigned them because I deleted that. That's fine. So here you can see that the task length is... I can't see it anymore. Task completed. All right, so we're going to make that public just so I can see it. All right, so it looks like it just gets continually reassigned to Alice because she happens to be the person first on the list. So I should probably sort the crew by their exhaustion levels. But guess what? There is no exhaustion level for the crews yet. So let's go ahead and add one just to be on the safe side. And what we'll do is we're going to just make that a stat. Public float exhaustion. Perfect, right? And then what we're going to need to do is have an hour passed here. We could link that to the crew quarters. That would probably save us some effort, but I think it would be a good idea to have the crew actually respond properly to hour passing. So public void awake. It doesn't need to be public. I just keep saying public because protected void awake. And we'll just sign that up. Universe.onHourPass.addListener hour passed. And then public void hour passed. And then here what we'll do is we'll say if there is no task, mathf or exhaustion equals exhaustion or minus equal of exhaustion equals if exhaustion is greater than 0.1f, then exhaustion, greater than or equal to 0.1f, then exhaustion equals 0.1f. Making this a float might be the wrong idea, but still got the same basic setup. Over here in the crew quarters, we're going to go ahead and return the crew, get the crew in the order that we want. So here in resting crew, we're going to go ahead and sort it. Now we have a couple of sorting functions already built, so we'll just copy and steal them because I don't feel like doing them again. So over here in functional room, we've got sort task. Copy that, drop it here into crew member. We could actually make it like an override or something, but whatever. So we're going to make this a public static int sort crew, crew member A, crew member B, and if A dot exhaustion is greater than B dot exhaustion, return 1. If B dot exhaustion is greater than A dot exhaustion, return -1, right? So with that in mind, what we're going to do is we are going to have these tasks have a certain load and exhaustiveness. So we'll go ahead and put that in here. Right above base task length. So public float exhaustiveness equals 3. And so when we complete it over here in the crew member, task completed, we're going to want to add that to our exhaustion. Exhaustion plus equals task.exhaustiveness. Easy as pie, right? And so over here, when we are actually grabbing the list of crew here in the crew members, we're going to want to sort this list after the fact. So m.sort, I can't sort a list. No, list.sort, and then we'll pass it the comparer. And I don't remember how to do that, so we'll just go ahead and grab it again. There it is. Comparison crew member. Comparison equals new comparison crew member. Crew member dot sort. I think we could just call that. Well, we'll call it sort crew. And then down here we'll say lists dot sort comparison. And we have to use system. Perfect. So that should give us a list that increases, and that means we shouldn't get Alice every single time, because Alice will get tired. So we'll hit play. And our task will get a character, George, Bob, Alice. See? Perfect. Now if we hit pause here and we actually look at the crew members in question, Alice is not exhausted, Bob is still slightly exhausted, and George is still slightly exhausted. So I'm not sure whether or not there are 2 tasks coming in or just 1, because we're not visualizing them yet. So that will be probably our next step. but my brain is at the edge of working because I spent so long doing stuff today. So I'm going to stop now, but let me know if you have any questions, and I will see you on Saturday. I might do some more modeling or something between now and then. Bye.